Children, listen. Chapter number 6. Application of derivatives, increasing and decreasing functions. Increasing and decreasing function we are going to see. Here, let me take one function first. Before that, increasing, decreasing function, we will see the definition. So, definition of increasing and decreasing function. So, in this, we should take any real function or real valued function. What does mean by real valued function? Na? The output means the range must be belongs to real number or subset of real number. Any real valued function we can take here. I'm taking one. What is that? First, let I be the domain. One interval. Okay. Be an interval. Be an interval contained in the domain of a real valued function. I'm taking real valued function. Okay, real valued function na range must be belongs to real number or subset of any real number. Understand? That is called a real valued function. Understand? Right. Next function f we are taking. Then f is said to be point number 1. Listen, point number 1. Suppose increasing function. What is that? F is a increasing function or increasing on I. Whatever the I we have taken in the interval, increasing on I. X1 less than X2. X1 less than X2 must be in the I. Okay, even X1, X2 also in I we should take. This implies what I am getting, increasing na no change in the symbol. F of X1 less than F of X2 you should take here for all that X1 comma X2 belongs to the domain, that is the interval I. Okay, what is the symbol ma? This is what ma? For all. Okay, or for all also you can write. Second point, strictly increasing on I if X1 less than X2 in I. This implies strictly, just increasing na equal will come, Daraja. Strictly increasing na equal will not come. Strictly increasing na equal will not come for all X1 comma X2 belongs to I. Listen carefully. Just see, just increasing na equal will come. Strictly increasing na here in the symbol equal will not come. So first one just increasing, so equal I gave. Second one strictly increasing, so that I didn't give equal. And third one, if it is constant, what is that? Constant on I. If I am taking any constant on the interval, if f of x is equal to c is the constant for all x belongs to the interval I, where what I said, c is constant. I said where c is what ma? Constant. F of x1 and x2. Very good, Raja. Ma here x1, second one x2. Good, Raja. Next, fourth point, decreasing. If I am taking a decreasing on I, if I take, if x1 less than x2 in I, this implies decreasing, just decreasing, so that f of x1 greater than or equal to f of x2 for all x1 comma x2 belongs to the I. See, just decreasing na, here opposite symbol, less than na greater than will be coming and equal also will be coming along with that. Okay, don't forget. Next, fifth point, strictly decreasing. Okay, strictly decreasing on I if x1 less than x2 in I, this implies f of x1 just greater than f of x2 for all x1 comma x2 belongs to the interval I. Okay, so this 5 point you should remember, Raja. So whenever we cannot differentiate the function, this definition will be very useful to find increasing and decreasing. Understand? Right. See, this is comma which I gave. This is comma. Okay. Right. Next theorem 1 will go pa. Next theorem, and before going theorem, I'll give some diagram which is increasing, decreasing. Diagram I'll give how the diagram will be increasing, how the diagram will be decreasing. That and all we'll see. Okay. Right. Have you done this? So whenever we assume the values, we have to assume less than, and less than only. Understand? Less than only we have to assume. Suppose just increasing, na, what we will be getting? The same less than will be coming, along with that equal will be adding extra. That is called a less than. Okay, less than function we can say. And what is that? Strictly increasing. Strictly increasing, na, that equal symbol will not come. Same less than symbol will be coming here. Okay, equal symbol not there, na, we have to say strictly. And next, same less than, sir, but less than opposite we are getting. Less than, na, here greater than or equal to we are getting. Equal is there, na, just opposite symbol. Less than, na, greater than when comes, we have to say decrease, but equal is there, na, just decrease. Understand? Right. And one more thing, strictly decreasing in the sense, when we have a less than, you will be getting opposite greater than. No equal also. No equal, na, it will be strictly decreasing. Understand? And last, third point is what? Constant. Constant function when we take, you will be getting what is that? Constant on the interval. It means when you draw the diagram, you will be getting one horizontal line or a vertical line. Understand? X, when you take y equal to x, sorry, y equal to k, because f of x will be taking ym, right? Then horizontal line only you will be getting. Understand? Right. I'm moving into the second, what is the diagram will go. Okay. In diagram, how we will see the decreasing, increasing and all, we'll see in a diagram. Right. Diagram you will take in a note. So in the note point, diagram first, listen pa, first diagram number 1 for a strictly increasing, function, if I'm taking, na, how the diagram will be. Strictly function, strictly increasing, if I'm taking, na, diagram will be like this. This is my x dash, y dash, and origin O. Now see, Raja, strictly increasing, na, your curve must be curve. This is curve. It can be anything. It will be going like this. So don't want to even slack also. You can go strictly keep on increase. It will be what, my dear? Keep on increasing. Understand? That is called strictly you can take. And second one what, na? Strictly decreasing function. Strictly decreasing function. Strictly decreasing function when you take, let's draw this x-axis, y-axis. This is my x dash, y dash, origin O. Suppose the curve will be coming from here. I will take another color. Suppose the curve will be coming from there. It is keep on going downward. It is a decreasing, strictly decreasing. From the top it is coming down. Suppose if I'm taking one more, what is that? Third one. Suppose horizontal line, okay, or neither increasing nor decreasing. neither increasing nor decreasing. Na? See here we have a two type of diagram. Horizontal line also neither increase nor decrease only. Suppose line is going, suppose if I'm drawing a, listen, this is my y x, x dash, what is that, y dash, origin O. Suppose if I'm drawing a flat line, this flat line if I'm drawing now, no, it is maintaining the same level, not increasing, not decreasing. This diagram also you can say neither increase, not decrease. One more diagram what now? One more diagram what? In the same function, this is my x dash, y, y dash, origin O, x. Listen carefully. You can take even any trigonometry function. Sine function will take. Sine function, it will be going through origin. It will be going like this, right? Listen carefully. Listen carefully. The function is increasing here and decreasing again. Again increasing, again it is decreasing. So this type of function also what we can say, neither increasing nor decreasing. In one question a function is going upward again downward, going upward again downward. Na? What we can say, neither increasing nor decreasing we can say. Understand? So these things you can take in a diagram. Next theorem number 1 I am moving. Theorem number 1. Theorem number 1 will go. Are you drawing ma? Boy side. Draw everything neatly ma. Curve and all you just draw by smooth hand itself. No need to draw like first. X-axis, y-axis alone use a ruler. Remaining things you can draw by your hand itself. Do it fast. Okay, next theorem 1 I said. By side pa. Then na good. But next theorem number 1. What is that? Theorem number 1. Theorem number 1 only very important point we are going to see Raja. Theorem number 1 or else whether you need example for before going theorem 1 I will give example for based on this theorem. Can I give one example? Only one example I will give. Okay. Example we will see based on the definition. Okay. So that example 7 I will give. Example 7 in our textbook I am giving. Show that the function given by f of x equal to 7x minus 3 is increasing. What we have to say is increasing on real number r. Listen carefully. Question is given. We have to show that function is increasing function on real number. Okay. So how we will be doing increasing, decreasing with help of what? We have to assume first x1 less than x2. This is the common point I said. Whether you will be checking increasing, decreasing or whatever, you have to take x1 less than x2. Understand? That I am going to take. So first of all, let's take that. Let x1 comma x2 be the any two numbers in interval in I. I means what here? I means a real number they gave. So that directly you write real number in R. Okay, in R we have to take. Now assume itself you write. Assume or let also you can write. Let first condition what? x1 less than x2. We are assuming like this. Now you have to bring the question 7x minus what is 7x minus 3. So multiple 7 on both the side pa. So that 7x1 less than 7x2 you will be getting. Now subtract 3 on both side. Okay, subtract 3 on both the sides. So 7x1 minus 3 less than 7x2 minus 3. See children, which is look like a, see f of x na we have here x. So suppose x1 na 1 it will be coming. So that same manner we have here 7x1 minus na you can write f of x1 less than this is f of x2. So that element x1 less than x2 and the function also f of x1 less than f of x2 na, what it will be? Listen, same, see, less than, same less than coming na. See, when we assumed x1 less than x2, function is also what? Less than na, what we have to say? Strictly increasing we have to say. What we have to say? Strictly increasing. Strictly increasing, also just increasing. Understand? We can say strictly increasing, also just increasing. Understand? Right. Now you can write that which is a increasing function. Okay. So that then f is what we can say? Strictly increasing function on real number R. Okay, on real number R. That's it. Sir, they asked only increasing, sir. We are giving strictly increasing, not issue. Strictly increasing, we can say increasing function. But increasing function, we cannot say strictly increasing. Understand? Be careful. So that this example you can take for the definitions which I gave. Okay. Next, theorem 1 will go. Theorem 1 with help of differentiative Raja means we will be differentiating in 5th chapter. One function is given now, we will be differentiating the function sum, right? With help of derivative, we are going to see increasing and decreasing. This is without derivative. Ma definition, in definition, I gave 5 point. All the 5 point without derivative I gave. Okay. Now in theorem 1, with help of derivative, how we are going to check a function is increasing function or a decreasing function. That is very important. Kindly listen. Have you done this? You have done, right? By said ma? Good. So theorem number 1. Everybody you write this. Theorem number 1. Right. There is a many point. That same thing I will write now. Let f be a continuous function. F be a continuous on closed interval a comma b and differentiable, continuous differentiable and all. We have a what is the continuous differentiable and all we have seen in the 5th chapter. Okay, continuous and differentiable on the open interval. Continuous and differentiable on the open interval a comma b. Then few points I will be giving. Point number 1. Listen. F is increasing. Suppose f is increasing in closed interval a comma b na. In closed interval a comma b, when we have to say with, listen, f is increasing in closed interval a comma b na, you have to check one condition. F derivative must be belongs to in the open interval a comma b, then only it will be possible. So that f dash of x must be greater than or equal to 0. Greater than or equal to 0 na, when you differentiate the function, you will be getting something. Okay, the x value if you substitute in the open interval, it will be giving some positive number. Positive number given na, we can say increasing function. Suppose negative answer coming na, decreasing function we have to say. So greater than or equal to 0 na, positive is the meaning. Okay, here for all x belongs to open interval a comma b. See, derivative must be open interval, increasing in the closed interval. Be careful, these points are very important. Be careful. And second point, suppose f is decreasing. Suppose f is decreasing in the closed interval a comma b if f dash of x less than 0. What we have to say pa? Less than 0 for all x belongs to the open interval a comma b. Suppose constant is, see in the derivative no strictly increasing, no strictly decreasing, only one, increasing or decreasing, that's it. Understand? Right. Next third point, what? Constant. Suppose f is constant, f is a constant function in closed interval a comma b if f dash of x, constant derivative what ra? What is constant derivative ma? 0. So that f dash of x you will be getting 0 for all x belongs to open interval. For all x belongs to the open interval a comma b, it will become a 0. Understand? So these 3 points very important. Based on that we will be seeing so what is that, we will go directly exercise. Okay, exercise directly we will see, or simple example if you want, I'll give simple example, or else in the previous question itself we will take. Children listen, the previous question, example 7, with help of definition we have done, which is increasing we are telling. Now with help of derivative also you can say which is a increasing or decreasing na. Same question I will take, f of x equal to 7x minus what is that, example 7, f of x, or else wait, example 7 I will copy. What is that, example 7 I will copy. Aha, many scribbling is there in question, it's okay, we will copy. So example 7 I am taking here. Raja, example 7, don't confuse with the scribbling. Huh? Right. Example 7, what is the answer? Let's go, ma. Listen, suppose f of x is equal to 7x minus 3. So with help of derivative, I am going to check whether it is increasing or decreasing. First you differentiate. F of x is equal to what I am getting? 7 into x derivative 1 minus 3 derivative 0. Okay. Then what I am getting? F dash of x which is equal to 7 ones are 7. 7 ones are 7. Listen carefully. We got f dash of x equal to 7. Am I right? Now here x value give whatever from the real number. They said from real, for all real number it should be increasing, they said. Am right? Now you give any value for x from the real number, what you will be getting? The 7 will be no changes. That already we have discussed. Okay, so constant na, see f dash of 1 if I am giving 7, or f dash of 3 I am giving 7. So whatever I am giving, constant never change. There is no x variable. How the value will change? It will be as it is. So that it will be greater than 0 for all x belongs to the real number. From real number you give any value, f dash of x became what ma? Greater than 0. F dash of x greater than 0. What we can say, f is a increasing function. With help of derivative, this is the way. With help of definition, this is the previous page. Okay, both the way acceptable in the exam. Whatever you feel good, you can use, not an issue. Understand? Right. So that what we can say with the help of definition pa, for all, okay, greater than 0, for all x belongs to real number, then f is increasing. F is increasing function on real number r. That's it, on real number r. So same question I have done with the help of derivative, same question I have done with the help of a definition. I hope you understand what is the way to do increasing and decreasing by using definition with the help of theorem also. Have you got idea? Right. Now we are entering in the exercise. Okay, children, thank you. We'll continue in the next video. Means the exercise will start in the freshly, will start in a new video. Okay, thank you, children. Take care. Bye. See you later.